All right, guys. So in our last lesson, we started talking about proportional relationships, and something that forms a proportion has a constant that is equal to each other when we divide our y divided by our x. Today we're going to be talking about tables and finding out if something's proportional based on a table, okay? And we'll decide that based on our y over our x. So number one says, you have been hired by your neighbors to babysit their children on Friday night. You are paid $8 per hour. Complete the table relating your pay to the number of hours you have worked. So this is my x, right? Because I'm going to always say my pay per hour. And usually in these tables, your x is on the left and your y is on the right, unless for some reason it's labeled otherwise. So for 1 hour, 1 times 8 is 8. I'll get $8. 2 hours, I'll get $16. 3 hours, all right, 4 times 1/2, or sorry, 4.5 times 8 is $36. 6 times 8 is 48. And then 6.5 times 8 will give me $52. So it says, based on the table above, is pay proportional to hours worked? How do you know? Well, to find out if something's proportional, we need to do our y over our x. So here, my pay is 8. That's 8 over 1. The next one, 16 over 2. My y over my x. This next line, we have 36 over 4.5. The next one is 48 divided by 6. And this last one is 52 divided by 6.5. If I type each of these into the calculator, 8 divided by 1, I get 8. 16 divided by 2, I get 8. 36 divided by 4.5, I get 8. 48 divided by 6, we get 8. 52 divided by 6.5, I get 8. So my y divided by my x all simplifies down to 8. And you're going to learn about this in 8th grade. It's called your constant. So based on the table above, is pay proportional to hours worked? How do you know? Yes, because my y's divided by my x's are all equivalent. For C, it says, how could you use this info to determine the pay for a week in which you worked 20 hours? Well, I know if I work 1 hour, that's $8. So if I work 20 hours, I should be able to do 8 times 20 to get $160. So two quantities are proportional to each other when there exists a constant number, and each measure in the first quantity x is multiplied by the constant to give you the second quantity y. All right, we're going to focus on finding that by dividing our y over our x in this lesson. For number 2, it says the table below represents the amount of snowfall in 5 counties in inches, 2 hours of a recent snowstorm. So when I look at this, I see my left-hand column is my x, my right-hand column is my y. So I need to find my y over x to see if these are proportional. So for this first one, my snowfall was 10 inches in 2 hours, so 10 over 2. The second one, my snowfall was 12 inches in 6 hours. My third one was 16 inches in 8 hours. My fourth one was 5 inches in 2.5 hours. And my sixth one would be 14 inches in 7 hours. Well, I need to divide these to see if they're equal. 10 divided by 2 is 5. 12 divided by 6 is 2. 16 divided by 8 is 2. 5 divided by 2.5 is 2. And 14 divided by 7 is also 2. Are those all equivalent? No. This one threw us off. So no, because our y over our x or y divided by x is not equal in all cases. So it's not proportional. Number 3 says the table shows the relationship between cost of renting a movie, which you guys probably don't know how to do. Maybe you do if it's a Redbox, in dollars, and the number of days you rented the movie. So our Y is the cost and X is the number of days. So back in the day, there used to be a place called Blockbuster. Ask your parents about it. They'll remember it. But on the weekends, we didn't have Netflix. We didn't have Hulu. We had to go rent those movies. And Blockbuster was the place we would go to rent movies. All right. So our Y over our X. We're trying to see if they're proportional. This first case, I get 2 over 6. Second case, we get 3 over 9. $3 for 9 movies. Fourth or third case, we get $8 for 24 movies. And this last one was $1 for 3 movies. If I divide these all in the calculator, 2 divided by 6, I get 0.3. 3 divided by 9, I get 0.3. 8 divided by 24, I'll get 0.3. And 1 divided by 3, I also get 0.3. So are these proportional? Is Y proportional to X? Yes. How do I know? All my Y divided by X's equal 0.3. And really it's 0.333 repeating, or 33 cents. Good job. All right, number 4. Our friend Randy is planning to drive from New Jersey to Florida. Every time Randy stops for gas, he records the distance traveled and the total number of gallons he's used. Assumed miles driven is proportional to gallons consumed in order to complete the table. So when I look at this, my X, we would always say miles per gallon, right? So if I write that down, miles per gallon, that means my Y is miles and my X is gallons. And we'll get into this here later this week. Oops, X and then Y. So I need to figure out in 1 gallon how many miles I could drive. To do that, I could use this column and do my Y over my X. Or I could use this column here. 216 divided by 8. In both situations, you're going to find out that if I divide those, I get 27. So that means I use 1 gallon of gas, I use 27, or I can drive 70, sorry. If I drive 1 mile, sorry, let's try this again. 1 gallon of gas, I can drive 27 miles. So to get 4 gallons, okay, I can drive a lot more than 54 miles. I'm going to take 4 times 27, and I will get 108 miles. I'm going to do this guy here, the 10. 10 times 27, I get 270. So 10 gallons of gas, I can drive 270 miles. Same thing here, 12 times 27, I get 324. Now for all these cases here, we've multiplied, but now we need to divide to figure out how many gallons I'll consume, or gallons of gas that are consumed if I drive 189 miles. So I'm going to do 189 divided by 27, and I get 7. Example 5 says, which team will win the race? You have decided to run in a long distance race. There are 2 teams you could join. Team A runs at a constant rate of 2.5 miles per hour. Team B runs 4 miles the first hour and then 2 miles after that every hour. So let's go ahead and fill out this information. Team A goes at 2.5 miles per hour. So that means after 1 hour, they're at 2.5. 2 hours, they're at 5 because 2 times 2.5 is 5. 3 hours, they're at 7.5. 4 hours, they're at 10. 5 hours, they're at 12.5. And 6 hours, they are at 15. All right. Well, Team B, their first hour went 4 miles, and every hour after that, they add 2 miles. So after that first hour, if I add 2, they have 6. If I add 2 to 6, they have 8. If I add 2, they have 10. If I add 2, they have 12. If I add 2, they have 14. So they want to know for which distance, or which team is their distance proportional to time? Well, Team A, because I multiply my x by 2.5 to get y, or my y over my x are equal. So what I could also do is come up here, so go ahead and do this with me, and if I were to prove that by doing my y over my x for Team B, I would get 4 over 1, which is 4. 6 over 2, which is 3. I can already see they're not equal, right? 8 divided by 3, which is 2.6 repeating. 10 divided by 4, which is 2.5. 12 divided by 5, which is 2.4. We can see none of these are equivalent. 14 divided by 6, you get 2.3, right? So Team B is not proportional. Team A is, because each time we're multiplying our hours by 2.5. Explain how you know distance for the other team is not proportional to time. My y over my x is not equivalent. For what length race would it be better to be on Team B than Team A? Well, really, anything over 5 miles, right? Because slow and steady, right? They had 2.5 miles to start, and they're going at 2.5 miles an hour. Anything after 4 or 5 miles here, at 4 miles, they're equal. So anything after 4 miles, you would want to be on Team A. All right. We're going to go ahead and skip this last one. We'll come back to it next week. All right. Go ahead and start your lesson 3 homework for me.